So, good morning, my dear students. So, in the last class, we were just discussing a problem on sensitivity analysis. Okay. So, today, let us continue with the same thing. So, in the last class, I think we have arrived at the optimal solutions for the two basic variables. So, that is x2 and x3. So these are the two values what we have obtained in the last class, where x2 is 40 by 3 and x3 is 800 by 3, right? And also the cost value, the optimum cost or the maximum profit also we have got it as a 28,000 divided by 3. So from that final table what we have got, so we will go to arrive at different coefficients, or the we can say find out certain values over here. So we have xb is equal to x3, x2, 800 by 3 and 40 by 3. Cb, the cost coefficient, original cost coefficient corresponding to the basic variable, the vector of the original cost coefficients corresponding to the basic variable, and also b is a matrix of original coefficients corresponding to the basic variable. And we have B inverse. B inverse we have determined, which we have got 4 by 15 minus 1 by 15 minus 1 by 50 and 1 by 150 and 2 by 75, and also the simplex multipliers, just like a pi. So we have got the transpose of the matrix CB and inverse of B matrix. So the product of these two, we will going to get the simplex multipliers. So this is what we arrived in the last class. Okay. So I hope everybody could be able to understand this, how we have got this optimal solution. Why? Because this is almost 60% of the work you have completed once you arrive at these the optimum values. So the remaining thing what we will go to discuss it now from today onwards is how we will go into use the sensitivity analysis approach for this kind of problems. So sensitivity analysis, in the sense, I think in the first class I just explained. So there are five basic types parameter changes that affect the optimal solution. One is changes in the right hand side constraints, cost coefficients, coefficients of constraints, addition of variables, and addition of constraints. So these are the five different ways in which you can change the parameters, and that will going to affect the optimal solution. So now we have arrived at the optimum values and the optimum solutions we have got it now. So now how these optimal changes or optimal solutions will going to change when you change any one of these parameters what we have listed out here. Okay, this is what we will going to apply the changes in the parameters, and we will going to determine how these changes will going to affect the optimal solutions. This is what we will going to put it in the form of a numerical problem now onwards. Okay, hope you people understood. Mithun and Sukru, any clarification?
No, sir.
So this table will plays a vital role from now onwards. So whatever things we have solved now, so everything is put it in the form of a vectors, and these vectors will be used in the further sensitivity analysis approaches. Okay, so I will go into discuss that now. Okay, yeah, yeah. Please make a note of these things. The first one, the first parameter change what we will going to do here is change in the right hand side constants bi. Changing the right hand side constants. So for that, just make a note of the problem statement. Find the effect of find the effect of changing the total time available. Change the effect of find the effect of find the effect of changing total time available per day, total time available per day on the two machines from 800 minutes to 800 minutes to 800 minutes, machines from 1200 and 800 minutes, machines from 1200 and 800 minutes to 1500 and 1000 minutes in the above example. 1500 and 1000 minutes in the above example. So this is a typical examination problem for you. So if the problem what we have given in the first statement is to determine the optimal solution, along with that they will going to give this statement also. What is the effect of, or find the effect of changing the total time available per day on the two machines from 1200 and 800 minutes to 1500 and 1000 minutes in the above example. So this is what we call it as the sensitivity analysis or post optimality solutions. So in the sense, when you change the any one of the parameters, so I just discussed the 5 different ways in which you can change the parameters which will going to affect the optimal solution. So this is one of the type of changing the parameter. So here what we are changing is we are changing the right hand side constants. The right hand side constants in the sense what is the total time available per day on the two machines is being changed. So in the actual problem, the total time available per day on the two machines is given as 1200 and 800. So 1200 for lathe and 800 is for milling machine. Now these values if you change, so 1200 has been changed to 1500 and 800 changed to 1000. Now what will be the effect of changing these values on the optimum solution? This is what we call it as the sensitivity analysis, right? So then how to solve this problem and how to check or how to determine what will be the effect of changing this parameter, that is the right hand side constants, on the optimum solution. So optimum solutions we have got it in the previous class. Now we will going to change 1200 and 800 to 1500 and 1000. Then we will going to determine what is the effect of that. Okay, so this is what we will going to do it now. Okay, are you following, my dear students, what I'm talking now? Mithun and Sukrut?
Yes, sir.
Okay.
Yes, sir.
So what actually in the problem you in the examination you will going to get it is the combination of the original problem statement what I discussed in the previous class, and apart from that this statement will also come. So then it will constitutes for 20 marks per. Okay, so what we got from the for the last class, that optimal solution, that carries 12 marks, and what we will going to do it now, that will carries, see, another 8 marks. So this is the first parameter change that we will going to study, and how it will going to affect the optimal solutions, that we will going to discuss it. Okay, yeah. See, for this, whenever you have the parameter change, which will be in the form of the changes in the right hand side constants, so you have to get this. So you can see here xi dash. So xi dash means is you are changing the variable values itself. So new basic variables you might need to have the new values of the basic variables. Okay, so xi dash is equal to xi plus, so this is the equation you're supposed to remember, the summation of j to j is equal to 1 to m, beta ij delta bj greater than or equal to 0. So now we will going to find out this equation. We will going to use this equation to find out the new variables, that is new variables for this problem when the right hand side constants has been changed. Okay, so now this equation, so please make a note of this equation. Everybody, I want you people to note down this equation where xi is the optimum value of the ith basic variable. I basic variable. This equation assumes that the variables are renumbered such that x1 to xm represents the basic variable. Please make a note of that equation.
Manoj, is it possible to speak?
Okay, let's continue now. Yeah. So in these things, so if the variables are not renumbered, the above equation will be applicable for I is equal to 3 and I is equal to 2. So we are not renumbered the variables here. It has been kept as usual how it was actually. Okay. So therefore, so now for this problem, the value of I is equal to 3 and I is equal to 2 in the present problem, with delta B3 is equal to 300 and delta B2 is equal to 200. So how you got this 300 and 200 means, so delta B3 is the difference in the two values what you have got it. See, previously it was 1200, now it has been changed to 1500. So the difference between the change in the parameter, that is the right hand side constants for the third right hand side constant is 300, 1500 minus 1200. So that will constitute delta B3. So delta B3 is 300. And a similar case, the second one, that is 800 to 1000. So 1000 minus 800. So you are going to get delta B2 is equal to 200. Please
on behalf of
remember this. So first you have to get delta B3 and delta B2. So B3, B2, why I'm talking about here means, so we are not changed or we are not renumbered the variables here. So all things has been kept as usual only. So therefore, so two basic variables what we have got is 3 and 2, x3 and x2. So therefore, I is equal to 2 and I is equal to 3 is the only thing what we are using over here. So therefore, we are getting delta B3 and delta B2. So delta B3 as 300 and delta B2 as 200. From the equation E1 to E5, the left hand sides of the above equation becomes. So what we have used in the last class equations, it is E1 to E5. So I listed out all those things. So now we will going to use this and we will going to write down that expression here. So same expression what we have this has been expanded. This equation has been expanded. So here xi, I have taken started from 3. I is equal to 3. Okay, I is equal to 3, xi is equal to x3 plus beta 33. Beta 33 plus delta b3. J is 3 also. We're going to start with j is equal to 3. Okay, so b3 plus beta 32. So next will be I will be 2 for us. So j will be 2 for us. So therefore, we will go to get. So I will remain same, but j will be keep on 3, 2. Only two values we will going to get. So delta beta 32 and delta b2. So this we will going to use it. So for x first equation, similarly for second equation also in the similar way where j is equal to 2. Sorry, I is equal to 2. I is equal to 2, you will going to use it here. So I is equal to 2. So we can get the expression for x3. So these two expressions you have to write. This is in continuation with this equation what we have written over here. Okay, only thing is you have to change with the 3 and 2. That's the only changes that you're supposed to bring it out over here. So x3, this equation you write it down and substitute the values. So x3, so value of the optimum solution values of x3 is 800 by 3 plus 4 by 15. So that is B33 to go back to the matrix what we have discussed in the previous one. So that is B33 is 4 by 15. Okay. And delta B3 is 300 minus, why minus? Because beta 32. What is beta 32? Beta 32 is minus 1 by 15. Okay. So minus 1 by 15. Minus 1 by 15 into delta B2, which is 200. So you will going to get it as 5000 by 15. So please try this. In the similar way for x2, same expression. So, but only the variables, that is I value and j value, will be keep on changing over here. So look at here. It is 40 by 3 plus 2 by 75 into 200 minus 1 by 150 into 300, which is equal to 2500 divided by 150. So please try this.
Manoj, this projection of solids is visible. Yeah. Okay.
Okay. So could you able to get these answers? Mithun?
Yes, sir.
This 5000 by 15, 2500 by 150. These two values you're supposed to get. Okay. Now, since both the values are greater than 0, okay, the original optimal basis B remains optimal even with the two new values of BI. The new values of basic variables are given by. So how we will going to get is xb dash is x3 dash by x2 dash, which is equal to xb plus delta of xb.
Manoj, is it visible now?
Okay, which is equal to xb plus b inverse of delta b. See, this you have to remember. These things you have to remember. Okay, so now xb means 800 by 3 and this is 40 by 3 plus b inverse matrix. So previous one we have b inverse matrix. So this is the b inverse, 4 by 15 minus 1 by 15 minus 1 by 150, 2 by 75. This is a b inverse matrix what we have. Okay, so substitute the values of the b inverse and delta b. Delta b is 300 and 200. So now you have to do the matrix operation. So please do the matrix operation and get the values as 1000 by 3 and 50 by 3. Please do it.
Okay, Manoj. Okay. Now, so this is a pentagonal prism. In this problem, what it's telling is base is inclined to be 30 degrees to telling edge of the base. So, and
Please do the matrix multiplication and addition and get me that value 1000 by 3 and 50 by 3. If you are getting the correct values, you just check it out.
axis is inclined to edge by 40 degree. in this problem, see here, the condition axis is 40 degree. The condition is wrong. And as usual, we are writing this top view and front view also writing. As usual, labeling or rational doing.
Got it?
And you are rotating the front view at an angle of 40 degree. And
Yes, sir.
you are going
Okay,
to
please, you have to do the matrix operation over here and you have to get these two values.
what the
Right.
change
Once you get these two values
it is
and the
still
optimum value of the
uh,
objective
edge.
function is given by.
that
So
is
now
which it is that edge is in fact
the new variables are
to
1000 by 3 and 50 by 3 because of this. And the optimum solution,
this is the edge.
optimum value of the objective function
This is
is
the
given
edge.
by. This is
That
what they have
edge is-
given here. So F minimum
This is appearing as a point there.
dash,
That
the
edge
new
is-
value of the optimum function or objective function is F minimum dash is equal to
This
F
is the
minimum
edge.
plus delta F.
Um,
So
A-
F minimum plus
A1,
F
A1
dash,
is the edge.
F delta F can be
A1
written as
edges
transpose of
diagonal
the CB into delta XB.
and projected.
Okay.
Here the
So
beta
now
will not
the
it is
previous
because
value was minus
the
28,000 by 3.
is
The cost
two
function, there is a
in
cost function we have plus
here are two length.
C
Yeah,
transpose. So I think we have got here CB transpose here. CB we have got minus 300 and 100, minus 100. But here we will going to have it as a transpose of that matrix. Transpose into delta XB. So delta XB
Therefore,
is, we are going to get it as
no beta. Beta will not come there. So this becomes as usual our problem. And let's go to the next problem.
Yeah, delta XP is the difference between the XB value 800 by 3 and 40 by 3, and the new value what we have got is 1000 by 3 and 50 by 3. So difference between those two you have to substitute here. So 1000 minus 800 divided by 3, so you're going to get 200 by 3, and 50 minus 40, 50 by 3 minus 40 by 3, so you're going to get 10 by 3. Okay. So substitute that and again just apply the matrix operation here and get me the value of the final optimum solution or new optimum solution. Please do it in your book. You have to do the matrix operation, otherwise it's very difficult for you at in the examination. You know how to multiply and how to add, how to get an inverse, how to get a transpose, how to get an adjoint of a matrix. These are all the basic matrix operations that you're supposed to learn. Okay, got it? Minus 35,000 by 3.
Yes, sir.
Yeah. So now the two changes what we observed is the variable has been changed. So x3 value, it was 800 by 3. Now it has become 1000 by 3. Okay. And x2 value was 40 by 3. Here we have got 50 by 3. So this is the changes in the optimum solutions while you are changing the one of the parameter. The parameter is the right hand side constants. Am I right? So and also the objective function value, the profit value. Initially it was minus 28,000 by 3 minus 28,000 by 3. Now due to that parameter changes, that maximum or profit will also be changed to 35,000 by 3. Look at that. Look at the changes what you can notice when you change, notice in the optimum values when you change the parameters, right? So now it has become 35,000 by 3 is the maximum profit what you will going to get it. So if you complete this, so this will constitutes for 20 marks in your examination. So any one of the parameter changes they will going to give, any one. So out of 5, anyone they can give, and they may ask you to complete the solution. So for all the problems till the optimum solutions, the solution will remain same. But only the changes they will going to give or parameter changes they will going to ask you to do is only later onwards. Okay, is it clear? Any clarification? Anybody? For when you want to change the parameter, which is in terms of the right hand side constants, so how the optimum solutions will go into change. So that comparison you supposed to make it out, and you should know how to make or how to change when the parameter changes. What are the parameters or what are the elements that needs to be considered while you are calculating or changing, getting the new optimum solutions. So either it might be in the form of a new variable values, or it might be a new objective function values. But you should be in a position to get that, and you should prove that. So because of the parameter change, that is right hand side constants have been changed, the optimum solutions are also changed. Is it clear, my dear students? Any clarification, Mithun, Sukrut?
No, sir.
No, sir.
So if you have any clarification, please just, because one question will be there for 20 marks in your exam. Definitely one question will be there. Should be in a position to answer that. Is it clear? Shall I move to the next parameter change?
Yes, sir.
Okay, right. Now, so we discussed one parameter change, the effect of one parameter change on the optimum solution. Now, the second parameter change, what we will going to discuss it now, is changes in the cost coefficients Cj. Changes in the cost coefficients Cj. So now, when the cost coefficients, that is the last row, what we have discussed, minus f. So if we change the cost coefficients of any one of the variables, okay, so now how the change in this parameter will going to affect the optimal solution. That is the one important thing what we will going to discuss it now. Okay. That is, in the previous problems, so when you just made the original table, see, this is the original table what we have, the cost coefficients, minus 45, minus 100, minus 30, minus 50, 0, 0, 1. So this is the original cost coefficients what they have given in the problem. Now what we are checking, what we are testing out is any one of these cost coefficients, any one of these has been changed. So how it will go into affect the optimal solutions. This is what the sensitivity analysis. In the previous problem, we have changed the right hand side coefficients. Now we are changing the cost coefficients. Okay. So let us check with the problem what they have given. So find the effect of changing C3, cost coefficient of 3, from minus 30 to minus 24 in the above example. So in this problem, he has given only one change in the cost coefficients. One of the cost coefficients has been changed. So that is for with respect to the variable 3. So where it was initially it was minus 30, now it has been made it as minus 24. Now if when this change happens, so what should be the effect of this change on the optimal solutions? This is what we will go to find it out. Now the how much amount of changes they have given? Minus 30 to minus 6. Means it has moved 6. Means 6 has been added to the minus 30. Hence it has become minus 24. So now therefore we can get delta C3. Delta C3 is a change in the cost coefficient value. So now initially it was minus 30. Now you have minus 30. Yeah, minus 24 minus of minus 24 minus of minus 30, it will become plus 30. So therefore it will become 6. So the difference between the older value and the newer value is plus 6. Okay, so this is the first thing what you're supposed to get it down. Then so one standard formula is there, but I don't want to discuss directly. You can remember this because in this case, we are not renumbering the variables here. So everything has been kept as usual, C3 and 2 only. So directly, I'm just writing the equation in the problem. So please, if you want much more clarity, you can look into the SSRAW textbook. It has given much more clarity, but I don't think it is very much useful in this category. Regarding that, you can just remember this formula and you can just complete the solution also. Okay. So now, when you change the one of the cost coefficients, the remaining cost coefficients C1, C4, C5, and C6 will also be gets changed. So how it gets changed and what amount it gets changed, so that you can use or you can determine by using this formula. So it is C1 bar or C1 dash or C1 dash bar. C1 bar dash is equal to C1 bar plus delta C1 minus delta C3 of A21 into beta 32 plus A31 into beta 33. So you have a general expression for that. So what I am writing it is the form of a C. So you have a general expression in terms of a summation. Okay, so you can look at the SSRAW textbook. There they have given that equation, and you can just understand that equation, how this can be used for obtaining the different values for that. Okay, so now for first cost coefficient, we are what is the changes you are observing or what is the changes you are going to notice that you can obtain in this way. Okay, so C1 bar plus delta C1 minus delta C3 into A21 in A21 into beta 32 plus A31 beta 33. So in the similar way, C4 dash. So wherever you have 1, replace it with 4. So if you remember one thing here, it is A21 B32 plus A31 B33. Then rest of things will remain same here. Okay, only thing for each one, the second suffix for A will be keep on changing. So beta value will remain same. Beta 32, beta 33, that will remain same. Only A value, that to only second suffix will going to be keep on changing over here. Okay, so that value how we will going to change, that depends upon what kind of coefficient, whether it is first coefficient or third coefficient or fourth coefficient or fifth coefficient you are using here. So based on that, you will going to change this, right? So now we have A21 into beta 32 plus A31 into beta 33. So this is the simple equation what we have it over here, right? So now we're going to substitute all these values from the tabular column what we have, and then we will going to get the what are the new cost coefficients because of changes in the cost coefficient across the third variable. Okay. Yeah. So now C1 is 25 by 3. C1 is 25 by 3. So how we got this C1 is 25 by 3 means
do some other problems.
Yeah. The last table, what you have seen. The last table. So what you have got here, the cost coefficient values. So you can see the last coefficient values what had 25 by 3. Okay, for the first one, it is 25 by 3. Am I right? So now this is what we call it as the C1 bar. So 25 by 3 plus delta C1. So delta C1 is not being changed over here. So JC1 remains constant. So therefore it will become 0 minus of delta C3 is 6 what we have got here into or a bracket, you open the bracket. So what we have, A21 is 3. A21 is 3. So go back to the first coefficient what we have, first table.
Not in syllabus.
Yeah. It's not enough. Yeah. A21. A21 because x2 is this one is here. It is the this is for the result of operation. Don't use this one now. Now go back to the first table. The table what we have got the original one. So where we have A2. So second is the second row corresponds to 2. The first row corresponds to 3. Remember always. First row corresponds to 3 and second row corresponds to 2. Okay. So 3 is the one what we have put here. 3 into minus 1 by 15. Beta 32. Beta 32 is the one which we have got from the final table. Beta 32. Beta 32 is minus 1 by 15. Minus 1 by 15. Okay. Next comes.
In this problem also, it is resting on this slanted edge.
Plus A31 is 7 and beta 33 is 4 by 15. Like this, you substitute all the values. So A corresponds to the original matrix. So there you can see original matrix. The first row is for the third variable and second row is for second variable. Because these are the only two basic variables what we are holding here. So please change accordingly with respect to the variables what you are writing down. Clear? So now, so substitute all these values and get what is the new value of the cost coefficients for the first variable, which you will going to get it as minus 5 by 3. Minus 5 by 3. Okay. In the similar way, you have to get a C4, C5 and C6. Same procedure, only A value will be keep on changing with respect to the second suffix of A. First suffix will remains 2 only in the first term and second term it will remains 3 only. So only second suffix will be keep on changing for A24, B32 plus A34, beta 33. So substitute all those values. Substitute all those values here. Then you will going to get, this is B34, I'm sorry, it is B34 I feel. This B34, beta 34. Okay, so then you will going to get the C4 is 8 by 3. Similarly, C5.
It's on one of its columns, so that it's containing.
Just a minute.
And the carbon is inclined to HP at 50 degree. So therefore, you should write in such a way that like this. In this way only you are writing, so that this is true length.
No, this is beta 232 correct. It is 32 only. Please change 32 only. It is not beta 32 correct. It is beta 32. Okay. So now substitute all those values and you will going to get it as 8 by 3. What it is written is correct. Beta 32, beta 32, beta 32 only. Here beta 33 only. You will going to get it. Okay. So you will going to get these values over here. It is 8 by 3. And similarly for C5. So you will going to get it as substituting those values. You will going to get 86 by 15. And C6 you will going to get it as 16 by 50. So these are the new values of the cost coefficients what you have got it. Okay, so now the change in the value of the objective function is given by delta f is equal to delta c3 into x3. Okay, which is equal to 48,000 by 3.
Solid.
So how we got this 48,000 by 3
is perpendicular to VP. It means this is the solid diagram. You should write the example like this, then join like this, join like this, join like this. I will show you once again this one.
How you got 48,000 by 3? Come back over here. Yeah.
Observe this carefully. Last class I will explain this one.
So x3 value is 800 by 3. Am I right? X3 value is 800 by 3. Now what it says, delta f is equal to delta c3 into x3. So delta c3 is how much? 6.
All sides are
Okay. And x3 value is 800 by 3. Delta c3 is 6 and x3 is 800 by 3. 800 into 6 is 48,000 by 3. So this is delta f, what you will going to get it. So now f is equal to minus 28,000 by 3, the previous value, the first value what we have got, plus 48,000 by 3, which is equal to 23,200 divided by 3. So this is the one what we have got, the change in the optimal solution or the objective function. Now what it says is, since C1 dash is a negative, so we have got this value as minus 5 by 3. Okay, we can bring x1 into the basis, thus we can start the optimal table of the original problem with a new values of the relative coefficients and improve the solution according to the regular procedure. So now substituting all these things, see here what we are getting, minus 5 by 3. So new values, you substitute new values, minus 5 by 3, 0, 0, 8 by 3, 86 by 15, 16 by 15. So this is this table will remain same, only you have to change the cost coefficients over here. Changing the cost coefficients, so you will go to get it is 23,200 divided by 3. So since one of the cost coefficient value is negative, so you have to do the pivot operation over here. So select this as the pivot column, and which is less than here, it is 160 and this will be 400. So the same procedure how we did in the previous classes, how to select the pivot operation, pivot column and pivot row. So pivot row will be selected based upon the ratio BI by IS. So 800 divided by 3 divided by 5 by 3. So you will go into 800 divided by 3 divided by 5. You will going to get 160. And here 40 divided by 3 divided by 130. So you will going to get 400. So now the minimum positive value of this is 160. So we will going to select this row as a pivot row and this as a pivot column, and the corresponding pivot element is 5 by 3. Got it? Now
this one,
you have to do the pivot operation. So here what happens, x3 will leaves the basis whereas x1 enters the basis. So therefore in the new table what you are going to get, x1 and x2. X1 and x2. So first table I think you can easily get it, how you can get this.
okay.
So pivot operation I explained, the similar way you can get the pivot operation over here. So x1 you have got like this and x2 we have got these values, whereas the cost objective, the cost coefficients will give it as 0 or positive values. Okay, so you can see since all the relative cost coefficients are non-negative, the present solution is optimum with, which is optimum with x1 as 160 and x2 as 8 and remaining x3, x4, xy and x's will be equal to 0. So from that you can get the objective function value, the maximum profit is $8,000.
This blue color line I will
So
draw.
this is how we will go into
This blue color,
complete
can you
the
see
problem.
one blue color line?
Got it? So
That is
please,
solid diagram.
if you have any
Solid
clarification,
diagram.
any
You
doubts
draw
anywhere,
like
you can
this.
talk to me.
I'm showing in the third position. Now
Mithun
you
and Sukrut.
see here.
No doubt, sir.
Okay, just to sit and practice at
See the
home,
third position.
because
Top here.
unless you practice, it's not
Now
so
it is
easy to
turning
do this.
horizontal or vertical.
Because we have discussed only 2 cases today.
Yes, good.
So any one case
So
will be
in that
given in
way,
your
so,
examination.
right.
Any one
Then
case.
I'll
You should
construct
be in a
this one.
position to solve,
Then
and you have to
project
get the
it, complete this.
new
That's all.
values, and we have to check it out for
This
what
one,
are
yeah.
the effects of these parameter changes that will bring to the
What are
optimal
the- And
solutions.
these are all similar
Okay,
problems.
all these things are already been
All this,
uploaded in the Google
yes.
Classroom, so you can just go through and you can just keep on practicing it in your
This problem,
notebook or a sheet of paper, whichever you are maintaining. Just complete this.
suspended problem.
Okay, so in tomorrow's class we will discuss another
This is-
2 different cases how we can do the parameter changes. That we are going to discuss in the tomorrow's class. Okay.
Yes, sir.
Okay. Thank you.
Yes, sir.
Next, the problem number 50. This is as usual